Well, the biofuels and bioproduct industry is really heavily influenced by our ability to show that as alternative fuels and products that we're able to take carbon that's emitted from its manufacture and usage and tie it up elsewhere in the biomass we use to grow those products there. So this part of the project, we're focusing on quantifying carbon in the plant biomass above and below ground, and also looking at how management practices, like the amount of vegetation that's returned to the soil during harvest with the energy cane, and growing legumes with those crops as part of the sweet sorghum cultivation. Well, we're looking at how those will affect nutrient management, nutrient cycling, as well as the microbial communities that are the agents that are responsible for nutrient cycling. Carbon's relevant to the biofuel and bioproduct industry because a lot of the public and private interests that are investing in biofuels are doing so because they see a need to offset fossil fuel usage with other types of fuels that are what we'd consider more carbon neutral, where the carbon that's emitted during the usage of and the manufacture of the product is tied up elsewhere in the biomass we use to create the product. The amount of carbon that's on site is influenced by several things. The genetics of the plants themselves, obviously things that grow quicker are going to tie up more carbon. Another pattern that's important is the allocation patterns of carbon in the plant. Some varieties will have a higher root system, and that's going to be something that remains in the soil a longer duration of time, so that's a more long-term storage form. And then management practices like organic matter retention, growing legumes with our crops, cover crops, all influence the amount of total carbon that's sequestered on site in biomass and in the soil. Fertilization is a practice that can really influence the amount of carbon on site. It's been shown that even though there's some carbon that's emitted during the manufacture and application of fertilization, the extra biomass gained from fertilizing a crop is so much greater that it actually, in aggregate, ties up more carbon than a non-fertilized crop. So far, one of the things we found from a carbon and nutrient budgeting standpoint in this project is that the previous land use has a pretty big impact when with what happens with nutrient cycling when it's converted into a bioenergy crop. Going from a pasture type situation or a fallow type situation has a bigger impact in terms of the amount of carbon and the nitrogen in the soil and the impact on the microbial communities than it does when we go from a row crop agriculture into an alternative row crop like energy cane or sweet sorghum. A new direction we're going with this project is we're now adding quantifying the gaseous emissions of carbon in addition to looking at the carbon that's in biomass and in the soil microbial community. And we're doing this as part of what we consider a cradle-to-grave carbon life cycle analysis of the production of the fuels from these crops here.